I want to go quickly through how to create the scatter plot and come up with the equation of the least squares regression line for this height and weight data like we did in class today. So again, the first thing you want to do on this is you want to enter the data on your calculator, right? And I've already done that, and I think that probably some of you still have that in your calculators as well. All right, so one of the things that we did is we set up, I'm going to second and then y equals, setting up the stat plot. So I choose the type of graph as this first one. Okay, I want list 1 and list 2, and I'm going to use the square as the symbol. All right, and then I need to exit out of here. And I've got it already set up so that if I just hit zoom and then the number 9, okay, this will give me the scatter plot of this height and weight data. Right? We talked about fairly strong positive association between height and weight. Right? And then what we did in class was we wanted to be able to come up with this least squares regression line. All right, so again, if you don't have the r and the r squared displayed on the screen today, and if maybe you got behind, I'm going to second, and then the 0 key is the catalog, and I'm going to arrow down to diagnostic on. Right, and again, once you turn this on, it stays on until you decide that you want to turn it off, which if you're in the stats class, you probably don't want to ever turn it off. All right, so it did it. Now, to find the equation of this least squares regression line here, I'm going to go to Stat, Calc. We talked about in class that there was 2 linear regressions. I'm going to go down to choice number 8. Okay, and it's going to ask me for what is my X list. Those numbers were stored in list 1. My Y list is the weights. Those were stored in list 2. And then I want to put this in a regression equation. All right. Those of you that have a newer operating system can hit alpha trace and it'll pop up this menu. If you don't have that and you want to store it, okay, you're going to come down here again. I suppose if it's asking you for this prompt, you probably have the newer operating system. But I can also get Y1 there by going to vars, yvars, function, and then choose Y1 there. Okay, and then calculate. All right, so then from here I can write down the equation. The y-intercept is the negative 146.7, and then the slope is b is 4.77, and then remember I put in, instead of x and y, I put in weight and height. Okay, and then again, the r and the r squared are displayed because I did that diagnostic on. All right, so some of you asked, can I finish the rest of the activities? And so I'm going to do that, but I also said that I would give you the equations here. All right, so if you put these numbers in list 1 and put these numbers in list 2 and do the stat, calc, linear regression, you're going to find that the equation of the least squares regression line here is 16.5 plus 8.51 times the number of people. All right, and then the r is 0.87. and the r squared is 75%. All right, so the strength of this relationship is about the same as the strength of this relationship. Okay, this 8.51, okay, this is the slope of the line, and it's a rate. Okay, it's the way you would interpret this is the model predicts that for each additional person in the party, the bill is going to increase by about $8.51. All right, so the units on this would be $8.51 per person. All right, now this isn't a buffet. If it was a buffet, then this R would be 1. You know, everybody's going to get paid, billed exactly the same amount. This $16.50 you can think of is if nobody was there, they still charge you $16.50 for no people. All right, so I guess that might make sense if maybe they charge you a deposit for the table. I don't know, you make your reservation, you make a deposit. If you don't show up, you don't get that deposit back. All right, but that's how much you would pay if 0 people showed up. Okay, and then also if this was a buffet, we'd expect that number to be 0. You know, it would just be the number of people times whatever the price is per plate, assuming that they don't charge extra for drinks and stuff like that. Okay, so 75% of the variability in this bill can be attributed to a linear relationship to the number of people that ate. So the other 25% would be, you know, we're not at a buffet, so I guess it's, did they have a salad? Did they have an appetizer before dinner? Did they have dessert? Did they have cocktails, or did they have soft drinks? So the other variability is going to basically come from what did they have for dinner. Okay, and then this next data set was a sample of some kids who took the ACT, and it was the number of hours of sleep they got the night before the exam and then the score that they received. Okay, I did the same thing here. Put these in list 1, put these in list 2, and then do stat, calc, number 8, linear regression, tell it list 1, list 2, and when y1. And so for this one, I get an equation that is score equals about 19.55 plus 0.46 times number of hours of sleep. Okay, so for this one, I think this one does have some meaning here. The 0.46, I'm going to say, is about a half. All right, so I'm going to say that the model predicts that for each additional hour of sleep you get, your score will increase by about 0.46 points. Okay, so about a half a point per hour of sleep. Okay, and then this 19.55 actually does have some context here. That means that if a person got 0 hours of sleep, the model predicts they're going to get about a 19.5. Okay, now if I said, you know, somebody was going to take the ACT, and they said, what do you think I'm going to score on this ACT? And I said, I don't know, how many hours of sleep are you going to get the night before? And they said, 10. I could take 10 and plug it in here, and I could get a prediction, right? But I think that most of you are probably thinking, well, that's probably not a very good prediction. And just because of the nature of sleep and scores, you probably know that there's probably not a high correlation here between these two. And in fact, the R is only like 0.176. Okay, this is one of those values that if you look at the scatter plot of this, and I don't have it available on my calculator right now, you would see just basically a scattering of points that has very little positive or negative association. In fact, probably a lot of you would just say the correlation is 0. And then this R squared just means that only 3% of the variation in these scores can be attributed to a linear relationship to the hours of sleep they got the night before the exam. Right? 97% of that variation comes from other sources like GPA, how many hours they spent doing review problems, what score they got in their math course this semester. You know, so lots and lots of other things are going to go into predicting a score other than the number of hours of sleep the night before the exam. So this one has a very weak but still slightly positive association. Right. We also have to be very careful with this, that we're not saying that that there's a cause and effect relationship here. We're just saying that there's a slight positive association. It could be that the smart kids actually go to sleep earlier. You know, they get more hours of sleep the night before the exam, or they take it more seriously. But it seems like that's a fairly weak association. Okay, so we're not saying that the sleep is going to cause your score. And in fact, when I did this in high school, one of my students said, that's all I have to do is like stay awake all night and I can get a 19.5. And that's not really what we're saying. There's not a very good predictor here. And we're not saying that the number of hours of sleep is going to cause your score. All right. And then on this last one, I put this one in here for a reason, because if you put these times, this is the time spent on social media, we'll say the day before an exam, and this is the score that the student got. All right, so when I put those into the calculator and do the same thing, I end up with score is equal to 92.8 minus 4.1 times the number of hours spent on social media. So for this one, this slope is negative, right? And that slope is negative means that the more time you spend over here on social media, it tends to lower your grade. Okay, is kind of what we're saying here. All right, so there's a negative association between time spent on social media and the score. Okay, And there's a fairly strong negative association here. And in fact, we're saying that 69% of the variation in these scores can be attributed to a linear relationship to the number of hours spent on social media. Okay? Which I think, it's not a cause and effect, but I think that generally speaking, if these kids weren't on social media, they might spend more time studying for the exam and so forth. Okay, so I would expect that you guys can put these numbers into your calculators and come up with these least squares regression lines. And in fact, I would encourage you to do at least one of these and just double check to make sure that you are getting the same results that I got. Okay? All right. And then I do want to go through this one. We didn't have time in class to do this, but we did calculate residuals. Right, and so we said in class that this negative 15.5 was the distance that this point is away from the line. And not only away from the line, but below the line. It has a negative residual. All right, what I didn't get a chance to do in class is talk about a residual plot. All right, and so with a residual plot, what we basically do is we're going to graph the, let's see, we're going to graph these were heights. We're going to graph heights, but instead of graphing them to weight, we're going to graph them to their residuals. So this guy that we calculated this residual for, he's going to be an ordered pair that is 76. So 76 along the horizontal axis and negative 15 on the vertical axis. All right, and so to make this residual plot, I'd have to calculate the residual for every single one of these guys. Right, now, what your calculator does is it will calculate those residuals for you. Right? I'm just going to double check that the last thing that I did here is a linear regression. Right? List 1 and list 2. All right, I'm not so interested in calculating the least squares regression line. I've already got that. All right, but it's going to give me that same output that we got today in class. All right, now, in addition to doing that, the calculator is also doing some work in the background. And if you go to second stat, and then under names, you're going to see L1 to L6. And then I have some other lists in here that I've stored. Okay, and you guys are going to find one in here that says resid. Okay, just like mine has a resid list. All right, and when I select that list, and then hit enter again, all right, you'll notice that this is a list of, I think it's 10 values, and this is the residual for the first person. Okay, if we calculated the residual for the next guy, there's his residual. And then the next guy, there's his residual. All right, so I've got this list that are residuals. All right, and what I'd like to do then is I want to make a graph that has along this axis the heights, and then along the vertical axis is the resids, or the residuals. All right, so we should end up with a point that's out here at 76 and negative 15.5. Okay, that's the one that we calculated up here. All right, I can create this residual plot. It's just second y equals. I'm going to use this first graph. Now, I think we used this one the last time we did it. We made a scatter plot. Okay, a residual plot is a scatter plot, but it's not a scatter plot of list 1 and list 2. It's a scatter plot of list 1, that's the heights, and the residuals. All right, so I'm going to put the cursor here, and I want to put the list resid in there. All right, so to get the resid in there, I'm going to hit second stat, and then I'm going to jump down here under names and find resid, and it'll paste it in there. Okay. And then I'm going to exit out of here, and I'm going to hit zoom and then the number 9. All right, so there's my residual plot. Okay, that guy that's here, okay, if I hit the trace button, okay, it takes me down to that point and it says that guy is 76 inches tall and his residual is negative 15.5. Okay, this is not something that you need to know how to do on the exam on Thursday, but it is something that we kind of ran out of time. I'm going to address this again next week on Tuesday, so we'll talk about this again. But one of the other things that we do with residual plots, and the way you can think about this residual plot is if you think about the least squares regression line, there's points that are above and below the line, and if you take that least squares regression line and collapse it down to the horizontal axis and drag the points with it, this is what you get. Right, so what I'm seeing here in terms of a pattern is a random scattering of points. I don't see a definite pattern here, which tells me that these points are kind of randomly scattered around the line, the least squares regression line. Right, and so what we can do with a residual plot is we can tell whether or not a linear model is appropriate. The more random scatter of points I see here is going to tell me, hey, the linear model is appropriate. The kinds of patterns that I'm talking about would be something like a parabola. If I see these points line up like a parabola like this, okay, that's going to tell me that these points that are up here have positive residuals, these points in the middle have negative residuals, and then these would have positive residuals. And if you think about what would that look like in the original scatter plot, you would see something that would be kind of concave upward. Okay, and in which case a linear model would probably not be very appropriate. Okay, another model would be one that looks like an upside down parabola. Okay, if that was the case, then our data would have kind of a downward concavity or a downward bend to the shape of the graph. Okay, so is a linear model appropriate for this data set? I'm going to say yes. Okay, and my reason is I just see a random scatter of points around the horizontal axis. Okay. All right, and then I am going to go through these again on Tuesday, but I think it would be worthwhile to take a look at these as well. This is actually an old AP statistics exam. So the question, I've drawn some stuff on here already, okay, just ahead of time. They gave us the equation of the least squares regression line, and what this line is for is the father's height is the explanatory variable, and then this is his daughter's height. Okay, and so this model says that the daughter's height can be predicted from the father's height by plugging into this formula. Okay, this 0.427 would represent for every inch that the father is tall, the daughter is going to end up being about a ½ inch taller. Okay, this 35.1 again does not have a lot of context. If you take this line and you take it back to where the horizontal or vertical axis is, it tells me that if a father is 0 inches tall, his daughter is going to be 35 inches tall. Okay, not much context there. Okay, so the first thing says draw the least squares regression line. All right, so what I did is I plugged in 80 into this function, and I got a point that was about 69 point something. Then I plugged 50 in, and I got a point that was about 56 point something. And then I just connected the dots. Okay, you could probably just eyeball this and draw a line, and you're going to be pretty accurate. Okay, then this one says that you've got a father's height is 67 and his daughter is 61. Okay, that's this ordered pair here that I've circled. It says circle the point on the scatter plot that represents the pair and draw the segment on the scatter plot that corresponds to the residual for it. All right, so this distance here would represent the residual. And then they want us to calculate the residual. All right, so remember that the residual is y minus y hat. Okay, the y value for that point is 61. The predicted y value, if we go up here to this equation, is 35.1 plus 0.427 times the father's height, and the father's height was 67. All right, so when we calculate that, I'm going to take 35.1 plus 0.427 times 67. All right, so the model predicts that she should be about 63.71 inches tall. All right, and then when I take 61 minus that, I get negative 2.7, I'm going to call it negative 2.71. All right, and it's negative because that point is below the line, and the distance that that point is below the line is about 2.7. Okay? All right, and then this next part is kind of conceptual, and this is something I think you probably should be aware of for the exam. It says, suppose that you've got a point 8471. Right, now the first time I read this, I didn't really think that much about these numbers, but you know what, this guy, the father, is 84 inches tall. 84 inches is 7 feet. Okay, he's really tall, and his daughter is 5'11". Okay, that point ends up being right up here. Okay, 8471. Okay, so that's a really tall guy and a really tall daughter. All right, and then it says, if that point is added to the data set, would the slope of the least squares regression line decrease? Would it increase, decrease, or stay about the same? All right, now, you've got to think about what's going to happen if I add that point to the data set. Okay, it seems to me that this line is not going to change much. And the reason that line is not going to change much is because that point is really close to the line. All right, so because of that, I'm going to say the slope stays about the same. All right, now you could argue that that point is just barely above the line, so the slope would actually increase a little bit, but I'm going to say that we're probably not even going to recognize it to 2 or 3 decimal places. Okay, so because that point is really close to the line, we're going to say it doesn't change the slope very much. Okay, and then the second question is, what about the correlation coefficient? Would the correlation coefficient increase, decrease, or stay about the same? Now remember, we talked about the values that are going to be influential in the correlation coefficient, and that's the ones that kind of live out here at the ends. And so with that point in there, this value is going to have a large z-score for both the x and the y. This is going to contribute a lot to the correlation coefficient. All right, and so there's 2 reasons for this. This is going to increase. This one remained about the same. This one is going to increase the correlation coefficient for 2 reasons. One, that point is out here where those influential points live, okay, in the extremes. Okay, and it's also going to increase the correlation coefficient because it's close to the line. Okay, if this ordered pair was, instead of being here close to the line, suppose it was down here somewhere. Okay, if I put a point here, I think that what's going to happen is that slope is going to come down. It's going to be kind of attracted to this point. And I think the correlation coefficient is going to decrease quite a bit. Okay, so 2 reasons why this is going to increase. If the value here is a large value for x, and because that point is close to the line. All right, and then this last one, this is about the number of seats on an airplane, and then this is the operating cost for the airline per hour. All right, and so the number of passenger seats, it looks like the more passenger seats there are, it looks to me like there's kind of a positive association here. Okay, we didn't talk about how to read this output here, but in this output, there is a predictor here that is constant, and that constant is 1136. And then this is the number of seats. This is the x value, and the coefficient of x is this. So the equation of this least squares regression line is y hat is equal to 1136 plus 14.673 times x. So x is the number of seats, y is the operating cost. Okay, so that's the equation. All right, you don't need to know how to read this output, and there's a bunch of other stuff here that we're not going to be concerned about yet, but you do notice that they do give us an r squared here, and we're not going to be interested in this r squared adjusted. Okay, so what is the value of the correlation coefficient? All right, well, if you recognize that r squared is 0.570, then to get r, you're going to take the square root of 0.57. And if you do that, square root of 0.57 is 0.755. Okay, now this is a place where we do have to kind of be careful because r could be 0.755, but R could also be negative 0.755. Okay? If you square either one of these, you're going to get 57%. Right? However, I know that there's a positive slope here, and R and the slope have to have the same sign. So 75.5%. Okay, now interpret the correlation coefficient. Now this one is 57% of the variation in operating costs can be attributed to a linear relationship to X. But they're not asking for that, they're asking for this. All right, so I'm going to say that 0.75 is relatively close to 1. So I'm going to say that this number indicates that there is a relatively strong positive association. Okay, and then this last part says, suppose that we're only interested in the range from 250 to 350. All right, so we're only interested in these planes. Okay, so think about getting rid of those values there. Okay, and then the question is, does the line shown on the scatter plot still provide the best description of the relationship to this data range? Why or why not? So if you look at these points here, does it look like this line is going to be a good fit? All right, and I think that what they're trying to get to is some people might say, well, half the points are above and half the points are below, like we did in class. But to me, it looks like there's going to be a different line that fits that data. And it looks like that line's probably going to do something like that to minimize the sum of the squares of the residuals. Okay, so the answer to this question would be no. I think that if we only looked at these points here, there would no longer be a positive association. In fact, it would be probably negative. Okay, so those are the kinds of conceptual questions. Again, you don't need to worry about being able to read this output. Kids that take AP statistics, that is one thing that they do need to be able to read. This is just some computer output. But answering questions like this, you know, come up with the equation of the least squares regression line. Now, did it say anything else here? So I could ask you to interpret the slope. So the slope would be whatever the operating cost per hour is. I'm assuming that this is going to be in, you know, it's in thousands of dollars. Okay, so for each additional seat, it looks like the price is going to increase by about $14 or $15. Okay, that's the way you would interpret that. Okay, so I think that that should finish up stuff that we did in class. Primarily, I just wanted to make this video so that you'd be able to remember how to put the stuff into your calculator and come up with the equation of the least squares regression line, and also to get the corresponding correlation coefficient and R squared. Okay? All right. Again, I've got office hours on Wednesday at noon. If you've got questions, feel free to drop in then. And then I will talk to you guys before you take your exam on Thursday and just give you, again, an overview of the expectations for the test. Okay? Remember that you may use a sheet of paper with whatever notes you want written on it. And you are also going to be not just able to use your calculator, but there are going to be some problems that you're going to be expected to use your calculator. Okay? All right. If I don't see you between now and then, good luck on the test, and I'll see you on Thursday.